look for it. So y hat is minus 23896.6. That's our intercept. And then, so that is a minus 709.13 fuel type diesel. Okay, so I'll just say diesel. Well, there are three categories. You need only two dummy variables. So it automatically created a dummy variable for diesel and petrol and left out CNG. Okay. Now, how are we going to interpret all that? How is CNG going to play a role in the equation? So we'll discuss all that in just a few minutes. Okay. So diesel and then minus 284.08, okay, approximately. So that would be petrol. And then plus 35.89, okay, approximately, weight times weight, and then minus 0.052 kilometers. So that's our y hat. So if you have a new set of x variables, then we can plug in those x variables into this equation and we can find y hat, which is what our predict command would do. Okay. But we need to understand what these coefficients mean. Okay, we'll look at that in just a second. And then we have standard error. Standard error is the standard error for the estimate. So now if you divide the standard error into the estimate, you get the t-table value. Okay? And then from the t-table value, you get the p-value. P-value is the probability that the variable is no good, in the sense that the coefficient is 0. The coefficient is 0, it doesn't matter what the variable value is, it's not going to do anything to that. So what is the probability that the slope is 0? That's what this p-value says. So this p-value says the probability that the slope is 0, well, don't worry about intercept. Okay, we don't have to worry about intercept. Okay, intercept we'll just delete. Okay, we don't have to worry about intercept. Okay, probability, and again, if you take diesel by itself and petrol by itself, the probability is 30% that it is 0. 67% it is 0. Okay, but again, there is a problem because these go together. And there is one more, CNG. So once again, we have to look at those in a slightly different way. So let's delete that also. We'll come back to it, but we're not going to look at how significant fuel type is here in the estimates. Okay. Then we have weight and kilometers, and they stand by itself, right? So this tells us that the probability that the slope is 0 is less than 0.00002. Okay, so that means it's most certainly not 0. It's most certainly a significant variable. Okay, the same here. Okay, this is the probability that the slope is 0 for kilometers is extremely small. So it's most certainly a significant variable. Okay? And then, of course, it says R squared says that, how good the fit is. So you have the variabilities in Y. So we'll talk about that in just a second. Okay. So now, from the ANOVA table, okay, we can get this part. When we ran the ANOVA command, we got this result, right? So let's copy that. Okay. And paste it here. Okay, and once again, we have to use data to, text to, what? Text to cells? Text to columns. Okay, we use text to columns to splice it up, right? And let's examine. So we will talk about what these stars mean in just a second. We don't need the stars here. Okay, so they look good. Finish that. And okay, so I'm going to copy that over here. Okay. And put the borders back.
How can we change it if it's messing up on our side?
What's that?
How can we fix it if it's not properly formatted?
You need to do what I just did, data text to columns. And if you're having difficulty, we'll talk about that afterwards. Okay. All right, so now we have the effects. Now the t-tests are repeated here. Okay. So now we have the weight and kilometers. It's the same like that, except now instead of estimate and standard error, we have what is called sum of squares. What is the amount of variability that that particular variable is able to explain? So there's a lot of variability in y, okay, and quite a bit of it is going to be explained by the regression equation in full. Now we are looking at how much contribution is each variable making for that explanation. And then there is residual. Residual is the variability that we are not able to explain. So that is beyond what this model is able to do. So here you get the mean square. So mean square is computed by dividing the sum of squares by the degrees of freedom. Okay. So each variable contributes 1 degree of freedom. Now you see fuel type, since it is a categorical variable with 3 levels, okay, are generated 2 dummy variables. So that is coming into the equation with 2 variables, and that's why the degrees of freedom is 2. So you divide that 2 into the sum of squares, okay, then you get the mean square. Then we have the residuals. Okay, residuals is the leftover variability that the model is not able to explain. Now that has a degrees of freedom 858. So that is n minus p minus 1. That's the formula. Okay, write that down. N minus p minus 1. Okay, n is the number of observations. P is the number of variables. So fuel type contributes 2 variables, and then you have 1 and 1, so there are 4 variables. P is equal to 4. So n minus p minus 1 is your degrees of freedom, and you divide the degrees of freedom into the sum of squares, you get your mean square for residuals. Or usually it is called MSE, mean square error. So now if you divide that mean square error into each of the mean squares, you get the f value and then the p value corresponding with f value. Okay. Now these 2f for weight in kilometers is going to be t squared. So if you take the t for weight and kilometers, you square that, you'll get exactly the f value here. So you can try that. Square that, you get this. Square that, you get this. Okay. So whatever decision based on the p-value that you make here is going to be the exact same decision that you will make here as well. Okay. It's just instead of t, it's presented as t squared in this. But what is important in this ANOVA table is the fuel type. So now fuel type is now presented to you as everything included. All the dummy variables are combined, and you have the contribution that fuel type is making for the model. And that p-value is 0.04. So that means if usually, but the default probability cutoff is 5%. If the probability that, remember, this is the probability that the coefficients are 0. Okay, it's no good. Okay, it's not making any contribution. That probability here is 4.6%. And the cutoff is 5%. Anything below 5% is, you take it as, okay, that's an important variable.